you?
I am good. I am good. Lots of shit going on though, man.
Well, so much that we didn't even get a podcast last week.
No, we're busy bees.
Well, let's tell everybody about all the cool things that we discovered then.
Should we move to Tuesdays? Because I'm gonna be I'll be in a hotel room on Friday. We could still do it. So
yeah, I'll see how that works. Hotel Wi-Fi. Good luck.
Well, yeah, that's true. Actually, we should probably move it to Tuesdays.
Yeah.
Okay. Yeah. What you got? What's going on?
Well, let's see. We've been writing documentation because we're trying to get real humans to use Kilroy, and they need some instructions.
Well, okay, there you go.
And I did. You know, I'm gonna hijack our agenda for a second because I got to tell you something that I just thought about last night. So I told you this. I've had forever. My mom had a database that she kept all her recipes in.
Oh yeah.
Started life as a HyperCard stack back in the 80s, believe it or not. And then I got her moved over to FileMaker Pro, and she diligently put every recipe she ever cooked and every note she ever had in this thing. And it had about 850 recipes in it. And she passed away a couple of years ago, and I put off saying, well, I got to do something with her recipe database. The rest of the family would like to have it. And finally, I said, you know what? I'm just going to do it. And yesterday, I popped open Visual Studio Code window and said, make me a recipe database out with a Express.js backend and a web front end.
Using what?
Just using the Copilot stuff inside of Visual Studio Code.
Gotcha.
And yeah, okay, whatever. Vibe coded up a web app. Everybody's done that. It's no big deal. But it was really interesting from two respects, because what this was really doing was a really, really fancy format conversion from an ancient HyperCard stack by way of FileMaker Pro into a SQLite database. Mm-hmm. So all of Mom's recipes are now in a more modern place that we can get at and interact with.
Got it.
And I had a discussion a couple of days ago with some people online about how really LLM's stellar use case in enterprise is format conversion. Hey, convert this XML document into JSON, or take this plain text and mark it up, or whatever it is. It does best when it's going from one text stream to another. Asking it to do anything else is a lie, right? It's just going to tell you a story. So I thought, well, you know, that's a really cool exercise in recovering some legacy data and using it as a tool. And I got to tell you, of all the things I've made it do, I was sitting on the sofa last night scrolling through the recipes, and every single one of them has a little comment. Oh, this recipe came from such and such who was in the bridge club, and she says make it with this extra bit of whatever, and all these little asides to the kids and to me, like, hey, don't share this recipe. This was your great grandmother's secret, and she swore us all the secrecy. Don't give it away. You know, I haven't had a conversation with Mom about food in 2 or 3 years, but here I was sitting on the sofa having one because for 30 minutes, I could vibe code up a stupid app to free her data so you could see it again.
I thought
that was pretty cool.
That's very cool. Well, speaking of vibe code, I'll show off a little bit too, because I can. Because
look at what I made over my summer break.
Let's see. Screen, slides, video. I guess screen is what this counts for. Here we go. So you and I manage a little bit of a little fund, and I was sick of the process I was using to manage it. So this is not completely live yet for us, but I actually have used it for reporting already. And it, I used something we're going to talk about today in conjunction with Claude Code, in conjunction utilizing models on synthetic. Kimi 2.5, as well as a little bit of Anthropic Opus 4.5.
Gosh, man, it is Frankenstein.
Well, the nice thing about, I will say this, the nice thing, despite all of the problems with OpenClaw, the nice thing about OpenClaw is that when you switch an LLM, the agent doesn't care because it has the context coming from its files that it's stored locally, so it doesn't lose a beat, you know? Whereas if you were trying to switch in a chat interface to another model, you're basically starting all over again. So anyway, I really love what it did. It came through with a lot of really cool shit that I love how it functions, and the interface is pretty decent. So all in all, it's probably a mess of code underneath, but I haven't looked at it, and I'm not the one that should. But it's a functional interface to the data that I need. Now, the really cool thing about this is I don't even have to use this interface. I can interact with this completely via the agent. I can have it enter trades. I can have it create reports, et cetera, et cetera. So anyway,
that's interesting. I had the thing that was making the little web app do that too, because in the data, all the recipes had a category. I didn't know what the full list of all the categories was.
Right.
And I needed a drop down so I could filter by category. I said, hey, go look in the database and figure out what all the categories are and make a drop down out of that.
Nice.
Right.
Nice.
I mean, that's kind of a subtle thing, but because it had the data to work from, and it was kind of clever. It fired up the server and it made a request and got all the results back, and then went through all the results and summed up all of the categories, and then you use that to create the HTML. So it talked to the app itself as a user to figure the stuff out.
Yeah, I love that. That's really cool. That's excellent. That's excellent. All right, let's take a look at, let me do a window share instead of just the tab. All right. So in terms of some news, all right. So first of all, I mean, this is the news of the week, 2 weeks, and that is this platform called OpenClaw. We're going to talk about that a little bit as it relates to Kilroy in a minute. But OpenClaw is essentially an agentic framework that is a hot mess of multiple applications and scripts, a lot of security issues. It has a lot of difficulty with managing its memory, although that's getting a little better, and its context. And the thing that makes it popular, though, is that it really does a pretty good job of acting like we would expect an agent to act. And it comes out of the box with integrations with Telegram and Discord, et cetera, et cetera. The cool thing about it is, though, that it does function well. It does loop through things. It does remember, but the foundations of it are markdown files. This kind of is inherited from Claude, which uses markdown files to manage its agent profile, et cetera. This has a soul file. It has an agent file. It has skills files, and skills files tell OpenClaw how to do things or how to carry out tasks, etc. The soul file tells it how to operate, how to approach tasks. And so what it does is it refers to those things to manage the things that it's working on. And despite it being a bit of a technical nightmare, despite it being a security nightmare, I have this installed on isolated machines. It does a fairly decent job from a functional perspective. And so that's the big news. We're going to talk about that in a minute. And as it relates to...
Before you go, I've got to chase a different rabbit here, because you just said some stuff in your description of OpenClaw that made me think of this. So, my buddy, Rudy Rucker, the science fiction author, who's one of the fathers of cyberpunk, he wrote a bunch of books back in the, I think, early 80s, maybe, the software, wetware, freeware. It's a tetralogy. It's 4 books, and in there, like, some of the leading characters are these sketchy robots that live on the moon called boppers. And boppers are just made out of piece parts and junk, and they assemble themselves and they write their own software, and it's this janky collection of robots that just crawl around on the moon and do stuff. And they have, every so often, they got to get together and, like, breed. They swap their software around and trade parts and make new versions of themselves. And when you were describing OpenClaw a minute ago, I thought, you know what? This is like the proto bopper here, man. This thing's putting itself together out of all these Frankenstein body parts. And
it's exactly, that's a perfect analogy, dude.
This is like the proto Rudy Rucker bopper right here.
Yeah, it works, but it's ugly.
I got to talk to him about this.
Yeah, it works, but it's ugly. But I mean, it's getting a huge amount of hype. And you know what I was thinking about, though? I wonder if this guy ever imagined that his little freaking markup language, Markdown, would end up, end up being the centerpiece of major advances in AI agentic.
I'll tell you, I wish that maybe they hadn't done Markdown, because it doesn't have very much semantic structure in it. I think you can have
Yeah.
nested lists. That's kind of about it. And I think the stuff that our buddy Don was doing with the YAML files is at least a next level up on the structure. Right.
I agree.
And I think that ultimately that structure is, to be able to collapse and hide things or sum up all these bullet points into one parent bullet point kind of model is really what's going to help these agentic systems keep track of their memory. Markdown's just too loose.
Yeah.
Right?
Well, and I think we might as well segue here. I've got more stuff to cover, but it's exactly what we've always said for the infrastructure of what we're building in Kilroy. And that is that managing that context gets convoluted and a nightmare when it's a prompt by itself, filled and filled and filled, or context like OpenClaw does it, where you have to constantly compact the context that's being fed back to the LLM because it gets too full too quickly. Like, I've got 192,000 character or token capability, and I'm compacting that, multiple times a day because all of the shit that this thing has to remember.
Well, and that's what we talked about. I think we were chatting yesterday about this. The problem continually with these things and with the way people use them is they're monoliths, right? I've got one big chat GPT chat session. I've got one big pile of OpenClaw markdown files. And the truth of the matter is that it's not how you don't go build a house with just a big ass hammer.
Right. Exactly.
So why do you have one big ass agent? You should have things partitioned better, right? You should have your software development agents, plural. You should have your calendar management agent. You should have your grocery store shopping agent, your portfolio management agent. You should have lots of subject matter experts in verticals that are partitioned away and have their very vertical bits of knowledge. I mean, it's been a problem in AI research for forever is you can make a really intelligent system if you make the problem domain narrow enough.
That's right. And that's what we've always focused on with being able to deploy hundreds or thousands of little agents to solve an issue, right? Like last night I was in the context of thinking about how
we gotta get Gruber off the screen. I've looked at him long enough now.
Oh, okay. In the context of thinking about how Kilroy can function to be superior to the power of OpenClaw, we have an infrastructure that allows us to have these swarms, these networks, and these which can be, connected to other people or connected amongst multiple agents within your system, or have multiple agents within a given swarm. That allows us to put context into very granular levels, right? It allows us to say, let's say you were trading, a bunch of bots and they were trading all kinds of pairs. Well, you could theoretically, this is what I was thinking about last night. You could theoretically have agents who own a pair, right? They know the volumes, they know the trade history. They don't have to know a lot more than that. They can tap another agent for market conditions, and then they can decide on a signal whether or not to take a trade because they know that domain, right? So you could have 1,000 pairs agents that are called every time a signal comes in and the identifier tokens come in and grab them, right?
Well, there's an analog in the equities world with market makers on a stock, right? They sit all day long and they watch the company and they watch their revenue and they watch their supply chains, and they are the market makers on that stock. And really what you're saying is, hey, do you want some agent market makers on your portfolio holdings, right?
Yep, exactly.
Same exact model. And you don't have one agent that trades 5,000 different equities, right?
No, of course not. Well, the bottom line is, we know that what we have in Kilroy can create not only superior performance from the perspective of context and knowledge within the system and managing that and recalling it to these monolithic markdown files, or, constantly having to clean out prompts, et cetera, because we're parsing it to the lowest common denominator. But we also have something that is self-contained, secured, encrypted, communications. So the ability for agents to talk to each other across machines or people or companies or networks. I mean, it opens the door to this self-contained system that has all the functionality you need to call built into it. And if it doesn't have something you need, you can develop a function for it that you can call. And it has a full-blown pipeline system that can eventually self-deploy these things, and allow agents to build out their own infrastructure. So I think it's got a really powerful model. And this woke me up. This tweet here by Kevin from Delphi Labs, which is a big investor in Web3 and AI. He said, if I can get back to it, he said, OpenClaw. Oh, I'm not. Am I showing this? Yeah. OpenClaw, formerly known as CloudBot for Enterprise, is the next billion-dollar opportunity. People using it on their own are going to demand it from their companies, but it needs to be reliable, performant, super scalable, flexible, no model lock-in, and of course, highly secure. Who's building it?
Well, we are. Yeah. Right. Hey, so
I mean, like every piece of that. This thing scales to infinity because you can just deploy more swarms. Right? Yeah. You can run it on a Raspberry Pi. You can run it on a server. You can run it on your MacBook. You can run it anywhere you want.
Run 50 of them in AWS, right?
Entirely flexible and dynamic. And if we get to the point where agents are self-deploying pieces, you could build an entire interview process in Kilroy to interview the employees of a company about what they do and how they do it and who they interact with, and map it all the fuck out for you.
And we've talked about this before. You've got an enterprise organization. You got 1,000 desktop machines sitting around with mostly idle CPUs. You run this in the background, and now you've got 1,000 node cluster of AI engine for everybody to use.
That's right. And then you can run the largest LLMs that are available.
I got to tell you, I want to tell you,
you don't have a bill that you're paying of $2 million left to Anthropic.
It's just your electric bill, but you were already paying that because people had to be able to play solitaire and Minesweeper, right?
Exactly.
I want to tell you a story about the background, like some ancient history about where Kilroy came from that you might not know. So back in the day, in the early 2000s, when I was chief architect for DARPA on the Joint Unmanned Combat Aircraft System, we had an interesting problem. We had lots of different unmanned aircraft that they wanted to have flown from the same control station. And Boeing, of course, wanted everybody to pick theirs, and Northrop Grumman wanted everybody to pick theirs. And as the chief architect with some R&D budget, I went off in the corner and said, no, we're going to show you guys how it needs to work. We're going to put an isolation layer in here on top of all your aircraft and on top of all your command consoles. So Boeing's can fly Northrop Grumman's plane and vice versa. And what it really was a precursor to what we did with Kilroy. We said all these aircraft all have the same kinds of functions. They can raise and lower the landing gear. They can change their airspeed. They can go up or down. They can use a sensor payload. They can drop a weapon. They can phone home for help. They can navigate around the mountain. They can all do all these standard operations. So we kind of came up with the full set of all the verbs that made sense for these aircraft to do. And we made a virtual control station and knew how to make all those commands onto the network in a standard form. And then the aircraft did what they needed to do to implement that command.
Oh, that's cool, man.
Right. So you could say climb to 5,000 feet, and you didn't have to say, well, in Northrop Grumman, that means throttle up and then adjust the elevator trim and do blah, blah, blah to get there. The plane could figure that out.
Well, I love that. You give it the goal and it breaks out the tasks.
Right. Well, that's what we did with Kilroy. So what are the things that you do? I'm gonna show my screen just so I have
I'll end mine.
Wave my mouse at, but I have to hit this share button. Hold on. Share window. All right, here comes the clown show. Don't try to figure out what this is really showing. We're just going to talk
I have to put it on. Hold on.
Yeah, so what we did with this particular view of the AI world is we said, who are the nouns in the system, right? We've got AI agents and chat agents and swarms and variable holders and some eye candy blocks and static viewers. And we've got a bunch of verbs, right? What are the verbs out there? They're things that people want to do, right? I want to get and set prompts on the thing. I want to interact with external data sources like webhooks and API calls. And I want to read and write files out of the local system. And I've got chat bots and things that I need to talk to out in the world for things like Telegram and WhatsApp and Discord. And so we came up with the basic set of nouns, and we came up with the basic set of verbs, and we gave people a place over here to hook the nouns and the verbs together.
Exactly.
Right. And the cool thing is that while this looks like a limited set of nouns and verbs, and it is, it's based on top of all the other substrate that's in Kilroy. And Kilroy has 100 plus functions inside of itself that run the same on every platform that Kilroy runs on. Yep. You don't have to worry about, is it big end or little end, integer values? Does it have, support for ASCII only, or is it going to have Unicode support? It doesn't care, right? We give you the same set of functions across every single platform. So it's really a high-level virtual operating system for all of these bots and agents and swarms and applications to live on top of, so that when you bundle up an app that you made on your machine and you ship it across a swarm to another user as a data file and they unbundle it, it's going to run the same way on their machine that it ran on yours.
Right. And now here's the powerful thing about all that. Back to kind of the analogy that you're giving of the control of the plane and breaking this down into the verbs. What happens in this process is when you start connecting to, say, APIs of your enterprise application, right, or as an external service provider, you now cut through all the bullshit of the structured UI that you spent 2 years building around that. And you can now grab the functions that exist within the whole system and see far more power that you had in your enterprise application or your API that you've been using than you ever had before. Because now you can break down in Kilroy proper as apps or functions, or within AI services in the pipeline editor, you can break down these granular functions of that API or of that application or of the data and make use of them in ways you never thought of before, and eventually unleash an agent to figure out ways to make use of them in ways you never thought of before.
Well, and what's really, you touched on something about the rigid, structured, already existing UIs. Web 2 is nothing but a bunch of rigid, structured UIs on top of backends that, if you did it right, you've got microservices or web services back there that you can call.
Yep.
And if you remember a couple of episodes ago when we were talking briefly about the mini apps, the ability, the thing that Kilroy does that's unique, and I think this is where, if we could ever push the Ouija board enough to get people to pay attention, the industry needs to go, is that everything that flows through these swarms is plain text, right? We send it around with a MIME type so you can tell, well, what kind of plain text is it? Is it JSON? Is it stringified JSON? Is it plain text? Is it markdown? Is it whatever? But it's just text. It's not a structured API call like MCP. It's not callbacks coming back from an LLM that tell me I've got to go make a tool call. These things all just talk to each other with text. And in some cases, for instance, in this particular example, the LLM can actually talk to itself and say, hey, you know what? I need to remember this. Let me put a message out into the command swarm that comes back to me as if a user typed it, that says, remember my stuff.
Right.
And it comes out and automatically compacts its context by summarizing it off in a memory file.
Yep.
And so we've got all these pieces that pull the back end pieces together and make them talk. But one of the things that you can do with this, which is really, really easy, is make some on-the-fly HTML that's simple. A couple of buttons, a fill-in-the-blank field. If the LLM needs some data and it wants it to be structured, give the user a little baby piece of user interface. It has a fill-in-the-blank form with 5 fields and a submit button, right? Don't ask them to type it out to you on the command line. Don't ask them to try to key in some JSON. Give them a fill-in-the-blank form and let them give you the data in the structured form that your agent is expecting it to do. So now suddenly, instead of just having agents making more agents and dealing with dumb terminal user interfaces on the back end, which is what OpenClaw is doing and everybody else has been doing with their web-based chat interfaces for forever, these agents can start to produce little dynamic snippets of user interface, present them to the user, and use those as their interaction mechanic to get more accurate user input, more usable user interface than forcing the user to type all the time. Right? Yep. If I want you to pick between 2 choices, which is easier? Pick between 2 buttons on the screen that you can click, or read the text and figure out what answer you're supposed to type or pick out of a list.
Yep.
Right. So the thing that I think is sort of the killer app on all this at some point is you now have an agent that doesn't just talk to you in text or talk to you in text to speech like a person agent, but it's actually building the things that you need to interact with it in a good way on the fly. And
yeah, I can build it on the fly, deploy
right.
it, give it to you, and then dump it. Right.
Right.
It's like,
Kilroy has this interface builder built into it. Those are all functions that the LLMs can call to put a form on the screen, to build some buttons, to make a pick list, to give the user the stuff that they want.
Dynamically generate a chart.
You're not even, yeah, right. We've got all sorts of data viewers, and you're not stuck with hoping that it generated some good HTML. It can use the blocks that already exist. So the same way that we have nouns and verbs for things in the pipeline, we have nouns and verbs for things in the user interface.
Yep.
Right.
Yeah. Give it the data and you could throw out your applications and
right.
And
so now you don't need to have, you don't need to have a bunch of people spinning up new web pages every time you need to make a change to the vacation request form.
That's right.
Right.
That's right.
You just give the AI a template of, well, here's what we need from people. Go get it from them when they ask to take time off.
Yep.
And let it figure it out. So the challenge, and this is another thing we talked about, the challenge is configuration management of that, right? When you're vibe coding up some application like a recipe database or a crypto investment fund management dashboard, maintenance becomes a problem because no human wrote that code. You don't know where the pieces are. And a good software developer has most good software developers have a weird mental model that they make and they keep of their software, whether it's visual or whether it's structural or language based or whatever. They got something in their head that they crawl all over to find problems, and they know this piece talks to that piece. You don't get that when something else wrote all that code for you.
That's right.
Right. And so you've got maintenance issues, you've got configuration management issues. All of a sudden something's not working. You don't know whose problem it is. You don't know where the problem is. You don't know how to fix it. And you're stuck forever having to ask these tools to fix themselves. And you're playing a game of telephone, right? It gets further and further away from the original code. I just had that problem yesterday. I wanted it to make some buttons work when you clicked on them and not when you moved the mouse outside of the button. It couldn't do it. Yeah. And it made gnarlier and gnarlier code and nested JavaScript. And I finally said stop and deleted all the stuff and did it by hand, right? Because it was small enough. In a big application, some big command and control system or some big process automation platform, you're never going to do that.
No.
Right. So what we can do with the way that this stuff is structured, because it's all data, is we can make templates. You got to make it this shape. It's got to look this way. The pipeline's going to do these steps, and you can change the variables, right? Just like these variables over here, what LLM is being used, what URL is it on, what's the context depth that I want, where am I storing my memory files, what does my system prompt look like, how many other agents am I allowed to spawn, whatever it is. You can parameterize those templates and have them get stood up, but the template bounds what's going to get created, right? So you're not going to just be making random stuff. You're going to be able to find where the problem was, and humans probably made those templates or
right.
at least improved them. So having a framework that's more mature, right, that was built by adults and not by agents or unruly hobby grade developers means that now I've got a platform. It's got all of the user interface that got concocted out of templates. It's got all the pipelines that were there, and I can snapshot it and I can save that away.
Yeah.
Right. Because Kilroy saves everything as data. All the applications are data. All the pipelines are data. All the UIs are data. And you can put data in a Git repo and version it. And if you need to roll back because the agent screwed something out, you can roll it back.
Yep.
Right. And so now enterprise is one of the things, for accountability. Prove to me that you went through these compliance steps. Well, here's our audited application. Here's all the agents and all the pipelines that were used to build it. And they're all saved away in the configuration management platform. And this is what we're using, Mr. Compliance officer.
Yeah.
And you can't do that with these ad hoc bailing wire, piece parted, duct taped, self-generated systems. They don't have that rigor that an enterprise needs. So
totally
man,
agree.
The dude that's looking for an enterprise solution probably should ask people who've built enterprise solutions before.
I'm just going to send him this video. And the cool thing is here, if you've ever encountered or talked to people that have to use some shitty enterprise application created by internal developers that have zero clue about UX and UI, you've seen how badly they want to change what they're using, right? Well, now imagine that you've parsed off, input fields and specific data segments, And the user says, you know what? I don't want to go through these 25 steps that you make me go through to get to the data entry screen I want. I just want to enter this data, right? I've got it. I've got to enter it, or I need to upload it. Well, now you could build that on the fly, right? They can say, hey, just give me a form to enter A, B, and C and deploy it into the system. I mean, obviously there's all kinds of checks and balances that go along with that. But anyway, yeah, I think we're exactly what that guy's looking for. So we're going to reach out. Awesome. Not to mention, the cool thing is, you know, not to offend our non-crypto watchers, but Delphi is also a crypto VC. So
right. Well,
what were you gonna say?
Well, nothing in particular, other than if we've got a little bit of time left, I was just going to show how we stitch together the verbs to do something more complex. We had this.
Yeah. Go ahead.
In our last podcast, this is a frightening little box right here. I'm zooming in on the one called load prompt. Right.
Right.
This is a command that the LLMs in this pipeline issue to themselves to change their behavior. Load a new prompt along with the memory that comes with it, right? And I prototyped this up. We didn't make every possible verb under the sun. We didn't have every possible block or command or noun in the system that you could have, but we have enough that, I know we've said this before, this is a Turing complete programming language for doing AI pipelines, and it just happens to be graphical.
Right.
This would normally be like a subroutine call in a programming language. It's doing lots of steps, right? And if we really wanted to make it efficient, we would figure out what's going on in this box and collapse it down to one more of these boxes that does everything. But for the time being, what this thing's trying to do is, I've got a system prompt and I've got some context that the user's given me. And now I want to remember things by taking all of the user's provided context and collapsing that into a summary and then appending it to my system prompt, right? Because that's the way I can tell the difference between what the users told me and what I remembered. Right. So in a Kilroy pipeline, the system prompt is also a storage of state and information. And when that state or information needs to change, the agent rewrites its own prompts. Yep. Right. And so in this case, what we're doing is a whole sequence of events of load the prompt from a file that's been saved, read in the system prompt, merge it with the memory that's been saved, write it out to a file called working memory, and then reload that back into myself as my system prompt. So you've always got the original system prompt in a file that was given, hey, your sea captain Billy Bob always talk like a pirate, and whatever your job is your system prompt. And then you might learn these things over time. Your ship's name is the Sally Mae, and you've got a parrot named One-Eyed Pete, and all these things that you tell it are getting added to the working memory and then concatenated to the system prompt. So when the user comes in and says, "What's your parrot's name?" on a brand new startup, it's already in the context because it was already in the system prompt. So this is an example of taking some low-level functions that Kilroy understands. Loading files and saving files and concatenating files and loading them in as prompts and stitching them all together to make a memory system, right? We can do every single function that people are using OpenClaw to do by putting together these primitives inside of Kilroy to do it. Somebody just has to sit down and do it, right? And you don't want something that spawns up, what is this, 5 or 7 agents in here get created to do memory. You just make one block that does memory.
Yeah, you turn that into a block, and then you just drag that block over and then configure it.
And Kilroy making a new block is go pick the Lego blocks and stitch them together and save them in a place, and now you got a new pipeline block. And you can also have the agents do that because they can pick the blocks and stitch them together.
Yeah, right? Exactly. And they can customize the structure of it or the interactions of it based on what you really need in a given situation.
So to put a bow around this, here's the deal. We have a really cool platform, and it really, really, really needs to get users on it. And it really needs to get done in a way that is not uncontrolled, right? We don't want to just dump a Git repo on some people and say, "Oh, have at it. Let's see what you make out of it." We really want to focus and curate and lead the development of this in the proper direction, right? And we've tried to do that by putting all these nouns and verbs together and giving people all the tools in the platform. But the reality of it is we need some partners early on that want to sit down and focus on building this the right way. Because if we go too much longer in this industry with this weird ad hoc random generation stuff, it's going to be a situation where you can't put the genie back in the bottle in any meaningful way. And these
Yep.
enterprise users are host, right?
Yep.
They're never going to
Totally
be able
agree.
to manage their business software again.
Yep. Totally agree. Awesome, man. That was excellent explanation. Beautiful.
Okie doke.
All right. Well, until next Tuesday, everybody. If you are interested, partnering, trying it, playing with it, building in it, talking about it, don't hesitate to reach out to us. I am B05 on Farcaster, B05 Crypto on Telegram and Twitter. Chuck is C Schotten everywhere. My and his DMs are open and direct casts are open. Do not hesitate to reach out. We'd really love to hear from you, and we'd love to partner with you. Thank you
Awesome.
very much. Have a good one.